Hello, sir.
Yeah, I'm back. Okay.
Yes, sir.
So let's continue with our activity. On a scale of 1 to 5, Grafty, I want
Yes, sir.
your preference for chocolate.
So I'll go for 3.
We'll go for 3. Becky?
Yes, sir.
5.
For 5. Yes, Becky, if you are said anything lower than that, I'll have my own comment to make. Osman?
I think I lost track, Jose.
Yes, rate your preference for chocolate on a scale of 1 to 5. Osman?
Yeah.
I said rate your preference.
I'll go for 1.
You go for 1. Good.
Yes, sir.
Bright?
I'll go for 2.
Go for 2. Daniel?
I'll go for 1.
You go for 1. Yeah. Very well. On that note, I'm going to ask a further question. Good. So within a month's time, or let me say within a period of 1 month, how many chocolates do you take? So the first person was Grafty. Yes.
Sir, 0.
You take 0. No chocolate.
What is A? Yes, sir.
Yes.
No
Becky.
chocolate.
Becky, how many? 3. How many chocolates within a month?
Yes.
How many? 3?
Yes, please. 3.
Okay. Who is the next person? Osman. Osman, it's your turn. Okay, let's take the next person. I think Bright is 2.
0.
Bright, 0. And Daniel. Daniel. Okay. So like you saw in our ratings, we had 3, 0. We had 5, 3.
The screen is not shared again.
Yeah.
I think Sir is out.
Yeah, I'm back. Can you see my screen?
Okay. Yes, sir.
Good.
Yes, please.
Yes, sir.
We had 3, 0, 5, 3. Then we had 2, 0. And I think Daniel also going for 0.
No, I went for 3.
Daniel went for 3.
Yes.
Wow. So clearly you can see that even when we rated having 5 as the highest. The person who said 5 takes 3 chocolates a month, whereas the person who said 1 also takes 3 chocolates a month. And the person who said 3 takes 0 chocolates a month. So you can see that this rating, even though they are still ratings, are based on perceptions. Okay? They are ratings based on what? Perception.
Perceptions.
Yeah. So they are sometimes relevant, okay, but not always true as they seem to be. Okay. So level ordinal are also ordinal, but they do not have clear-cut intervals between them, because the person saying 5, okay, probably is saying 5 because we are getting close to Valentine. Okay. Yes. Might be saying 5 because we are getting close to Valentine. The next time you ask him in March or in April, he will tell you, no, my choice is not 5, it's rather 3. So that is how the level ordinal scale also works. Okay, any questions so far?
So far, I'm cool.
Very well. Okay, so this gives us the types of variables. Let me summarize it again. We have 2 main types of variables. We have quantitative, we have qualitative. Then under quantitative, we have continuous and discrete. Under qualitative, we have nominal and ordinal qualitative. Then even under the ordinal, we say we have ranks and levels. Okay,
Levels.
we have ranks and levels. Good. Then let's also summarize the form of measuring or obtaining the data. So when it comes to discrete quantitative, we count. Okay, so discrete quantitative, we count. Whereas when we go to continuous quantitative, we measure. And when it comes to nominal, like gender, okay, if you want gender, you only have to sort between males and females, okay? So nominal, we sort. And then when it comes to ordinal variable, we order them, okay? So this is order.
Rank level. Okay.
Order them. Very good. Then don't also forget the coding, okay? So coding, you always take from the least to the highest. So if, then in terms of the nominal, where there is no order, so if you have gender, and we have male and female. Okay, let me better still go back to the table. So for gender, we can assign 0 to female and 1 to male, or assign 0 to male and 1 to female. So we can say that male is 0. So instead of putting 0 in the table, male in the table, you put 0, 1, 1.
Male.
Then you inform the computer that 0 means male. It doesn't mean that female is higher than male, okay? That is how we do the coding. Very well. Now, we're moving on to our next topic. Before we do that, make sure you have your scientific calculators by you. Okay, we are looking at frequency distribution tables. So try and get access to your scientific calculators whilst I do a very simple demonstration on just what we've just learned to you. Okay. I'm sure you have your calculators by now. I want to simply demonstrate the coding to you, because coding is a practical thing. So I want to demonstrate that briefly. So I have my SPSS sheet created. I hope you can see the sheet, the spreadsheet.
Yes, sir.
Yes, sir.
So I'm creating the variable gender. Okay. And then I need to tell, I'm going to type numeric values, but I need to tell the computer the input is what? It's a nominal input. Okay. Good. And also tell the computer that I have what? 0 as male and 1 as what? As female. Okay. Good. So I add and then click OK. Now when I come here, I'm going to input data for 5 people. So I have 0, 1, 1, 1, 0, 0. Okay. So seeing this data with the definitions I have inputted, right? Once I click on this label values, you can see that the numbers have changed back to the actual data I picked from them into male and female, okay? Which means that the computer recognizes that these values are not numeric, they are nominal. They are nominal and they are qualitative. So even though we put 0 and 1, but they are nominal and qualitative. Okay. So now let's go on to topic 2. If you have any question, you can ask. And usually after this topic, we are supposed to take an assignment. This is a summary of your notes, your Lima's notes. And there is an assignment. I'll post the assignment right after class. Okay, that is not part of your MCA. But as you're aware, this course requires that you do more hands-on, okay, practice. So you have to solve that as an assignment for me. The activities below the slide, but I'll specify it on the WhatsApp for you. And make sure you do an independent work and submit as well. Okay. Now the next topic we're looking at is frequency distributions. And like I said, frequency distributions are relevant, okay, in helping us to get a snapshot or an overview of the data we have what we have collected at hand. Okay, and usually they are very relevant when we come to qualitative what or let me say qualitative papers, okay, or papers based on qualitative analysis. So I'm going to go online and I want you to follow me online on ResearchGate. And you can also check on Google. I hope you can see me online.
Yes,
I'm
sir.
going to
Yes.
check for a number of papers. Just pick one paper. So parental motivations by Michael. Okay. So try and follow me online on ResearchGate. I have a number of articles. I'm building a huge profile to become a professor very soon. Okay, so try and help me. Just follow me wherever I am online. Okay, so that I can also be a professor. Then when it's time for you to be a professor, I can also be your reference. Okay, so let me go here.
Yes, sir.
Okay.
Okay. So we want to go to this article. Yeah, so you get to this journal, we can let's download this. So we got this article here. Okay, which is a very nice article. You can go to ResearchGate as well to get it. It's talking about parental motivations and involvement, a developing country perspective. Okay, and with reference to what we're doing today, which is on frequency distribution tables. Okay, frequency distribution tables help us and to at least get an overview of how things are. Okay, here I think this is a purely qualitative paper, but at least you can see some percentages in there telling us, it says an examination of responses provided revealed that most parents who responded yes in deprived districts were more influenced by their neighbors and community influence. That's 42.9%. Okay, so another thing that frequency tables help us to do is to re-express the observation, the frequencies we observed in percentages, okay, and help us to do some comparison among various what categories. Okay, good. Now, how do we get the categories? How do we build these categories? And I believe we all have a basic idea of how we build categories, just that at the lower level, you are given the intervals. You'll be told, okay, with an interval of 1 to 10, 11 to 20, 21 to 30, construct a frequency distribution what table. But at this level, we need to go beyond that because at the lower level, it was just an introduction. So let's say that these are examination scores. I hope you can see my screen.
Yes, sir.
Yeah. These are examination scores from 40 students in a class. And we are to construct a frequency distribution table for the data. Now, the first step is you have to calculate the number of classes. And that is given by the formula, we call it the Sturgis rule. The Sturgis rule. The Sturgis rule. Okay, the Sturgis rule. Good. So we are to determine the number of classes, and we determine that using 1 plus 3.33 to log of n. The log of n should be here. So it is times log of what? N. Where n is the number of observations. So in this case, our n will be what? 40. Okay, good. So in this scenario where we have 40 observations, we are going to have k will be equal to 1. I think the formula is there. So find log 40, multiply by 3.332, and then add it to 1 for b. Log of 40 times 3.332. What are we getting? What are we getting? What did you get? Yeah, Grafty, what did you get?
Yes, sir.
Yes.
Yes, please, I don't have a calculator.
Sir, I
Yeah.
got 5.338, 5.334, let me see.
So your K to be
6.3.
Yes.
6.33. Okay, thank you.
338.
338. Okay. So that is step one. And this is the value of K. But you see, K is the number of classes. And like we know, number of classes have to be in whole numbers, okay? Discrete numbers. Now, the secret here is we can either round it off up or below, but you need to be informed on the next calculation we're going to do. So now, step two is to calculate to find the range. The range, okay, let me put it in full. The range is your maximum minus the minimum observation minus the minimum observation. So that will be, let's look for the maximum. Maximum will be, I'm seeing 84. I can see 84 to be the maximum. Are you seeing the same?
Yes, sir.
Yes,
Yes, sir.
84 is the maximum. And the minimum
Yes.
is, I think minimum is 18 here.
18.
18.
Yeah.
So 84 minus 18 should give us what? 60 what?
66, sir.
66. Okay. So in step 3, we are supposed to calculate the class width. Okay. The class width. Now the class width is the range over the value of K, which is the class size, the number of classes, sorry. Good. So the range here is 66. So 66 over, now we can decide on the K. Like I said, you could have rounded your K off to 6 or to what? To 7. Okay? So either we use 6 classes or 7 classes. But you see, when we get here, because the numerator is 6, I think it will be easier approximating it to 6, K to 6. So instead of 7, we'll rather use K to be what? 6. I hope that step is clear.
Yes, sir.
Yes, sir.
So this will give us a class weight to be 11. Good.
11.
Yeah. So once we've obtained the class weight to be 11, we'll have to now come and calculate your lower limit, your lower class limits, the lower limits, and the upper limits. With the lower limit, you first select the smallest value, in this case 18, or
Yes.
a value just below the smallest value. So we can use 18 as the first value, or we can use 17 as the first value. Okay? Because we are creating an interval, if we use 18, 18 will be on just on the boundary or on the lower limit, okay? To be the lower limit. Whereas 17 would still include 18 as part of its interval. So we can use 18 or 17 depending on what you want to use. Then the next thing is to keep adding the class width till we have covered to the highest observation in the data. So we're going to add 11, that will make it 29.
20. Sorry, 25.
29, okay, plus 11 again, should make it what? 29 plus 11 should give us what? 40. Are you with me?
Yeah.
Yes, sir.
Yeah. Are you all with me?
Yes,
Yes,
sir.
Yes, sir.
Plus
Yes.
11 should give us
Yeah.
40.
51.
51.
Plus
Plus 11 will give us what? 62.
62.
Plus 11 will give us 73.
73.
And then finally, plus 11 will give us
And then
84.
84.
84.
Good. So this will be our classes. Let me clean it and write it better. So I'm going to clean this. Okay. So let me start from a bit up. We have 18. We have 29. We have 40. We have 51. We have 62. We have 73. And we have 84. Good. Then for the upper limits, the upper limit is always the upper limit of the first class, okay, is 1 unit below the lower limit of the next class. So that is going to be 29
20.
minus 1 unit.
Okay.
Good. Now, what is 1 unit in a unit in whole numbers? It's 1, not so.
Yes, sir.
Good. A unit is 1.
It's 1.
It's
Yes.
1.
Yes. So 29 minus 1 is going to be what? It's going to be 28.
28.
Are you getting it?
Sir,
Yes.
Yes, sir.
yes, I don't know how we got the 1 unit.
1 unit, that is the rule I'm telling you.
Oh, okay,
So if you
okay.
want the upper limit, you subtract 1 unit
Unit.
from,
Okay,
yes, the lower limit of the next class.
right.
Okay. So once you do that, that will be 29 minus 28. But take note, 1 unit is for the unit of the data. So this data is in whole numbers. That is why the unit is 1. If we were in 1 decimal places, then the unit will be what? 0.1. If the data was in 1 decimal place,
1.
yes, the unit will be is 0.1. And if we were in 2 decimal places, the unit will be what? 0.01, because we are in a hundredth.
101.
Okay, then you will be in the hundredth. So you take note of that. Now let's continue. So like we said, to obtain the upper class limit for a class, you just subtract 1 from the lower limit of the next class. For this class, it's going to be 39. For the next class, it's going to be what? 50. For the next class, it will be what? 61.
61.
For the next class, it's going to be what? 72.
72.
Next class is going to be
83.
83.
83.
Good. Now, if you look carefully at the intervals between the classes, 40 to 50 is 10. 51 to 61 is 10. 62 to 72 is 10, right? 73
Correct.
is 10. So it
So
means
that
that
is
the
going to
final class will be
94.
what? 94. Is it clear?
Yes, sir.
Correct.
Yes, sir.
Good.
Yeah.
Very good. Okay. So this is 29. Then the next thing we have to do is to construct what we call as a tallies. Or better still, let's write the class limits down properly. So our class limits is, let me rearrange this a bit. So we need the data as well as a table. So I need to do rearrangement. So we'll take our the data up. Then let's construct our class limits. So we have our class limits is now what? 18 to 29. 29, sorry, to 28, sorry. This is 28 here. 20,
Yeah.
29 to 39. We have 40 to 50. We have 51 to 61. We got 62 to 72. We got 73 to 83. And then finally 84 to 94. Good. This gives us our class limit. Then the next thing is we have to do some counting and get our tallies. So for 18 to 28, we have to count the number of observations that fall between 18 to 28. So let's go to the first column, none. We go to the next column. This is 18 to 28, so we got 1. Have you seen it? Did you
Yes,
see?
sir.
Yeah, good. So 1. Then next column, we have 2 here. We got 26 here, so 2. Okay.
Yes, sir.
So we have 2. So we have 1 and 2. Okay. Then let's go to the next category. We have 29 to 39. First column, there is none here. Second, there is none. Third, we have 36 here. So we got 1. Fourth, there is none. Fifth, there is 1 here. That is 38. So we have 2. Sixth, we have 34. So we got 3. The seventh column, we don't have. 8, we don't have. So we have 3. Then we move on to 40 to 50. First column,
Today.
45.
1.
So 1. Next column, we have none.
None.
Next column, none. Next
None.
column, none. Next column, we got
None.
50 here, so 2.
None. 50.
Yeah,
So
50.
2.
Here, 2. So we come here, none.
43.
Yeah, we got 3 here. Then we come down. This is 44. So
Yeah, we
4.
missed 1. And the column, there's 43.
Yeah, 43. That's
And 34, we have 43.
yes, I've seen that. So 43, we cross that 2 out. 43. So when you count to 5, you use the fifth as a bundle. Okay. Then we go to the next column. We have 44 here. So we take that. That will give us 44. Then the next one is 51 to 61. We have 1. We have 2. So let's take that 1, 2. The next column, we have 3. 4.
Four.
So 1, 2. Next column we have 5.
5.
So 5 is a bundle. Next column we have 6. We start anew. Next column we have
7.
7. Next column we have 8,
3. Yeah.
9,
9.
10. So 8, 9, 10. Next column we have
Another 3.
11, 12,
12. 13.
13. So 1, 2, 3. The next column we have 1,
3 additional 1. 16.
2, 3. So we have 1, 2, and 3. Good. We're done with that category. So we move on to 62 to 72. First column we have 1. Next column we have 2, 3. Next column we have 4, 5. So 4, 5. Next column we have 6, 7. So 1, 2. Next column, let me cross it out well. Next column we have 1, 2. So 1, 2 here. Then this is crossed out, this is crossed out. We left with 1 here. So last
Yes.
one here. Good. Then 73 to 83. We go to the first column, we got 1.
Then 2.
We got
Third column.
2 here.
That's it.
And then, okay, so that's it. Then finally, we got one last observation here, which is 84. So we got that. Yeah, good. Okay. So we'll have the frequency for the corresponding tallies, which will be 2, 3, 6,
6.
this 15, so 16
16.
is 10.
10.